Let's look at moments and finding the distance of the center of mass. So the question says a non-uniform rod AB is 3 meters long and has weight 20 newtons. It is in equilibrium on supports C and D, where AC is 1 meter and AD is 2.5 meters. The magnitude of the reaction at C is 3 times the magnitude of the reaction at D. Find the distance of the center of mass of the rod from A. And here we have a diagram of the rod. First thing we can do is annotate this with the relevant values that we've been given. So we know that the distance from A to C is equal to 1 meter from the question. We also know the distance from A to D is equal to 2.5 meters. And so therefore, if A to C is 1 meter and A to D is 2.5 meters, then the distance from C to D must be 1.5 meters. And then we have the distance from D to B, which now must be equal to 0.5, because 2.5 meters plus 0.5 meters gives us 3 meters. We also know that the magnitude of the reaction at C is 3 times the magnitude of the reaction at D. If we label the reaction force at D as R, then we know that the reaction force at C must be 3 times this. So 3 times R gives us 3R. Finally, we also know that the non-uniform rod has a weight of 20 newtons. So since the rod is non-uniform, the weight doesn't act in the center, and so we're going to place the 20 newtons anywhere on the rod, say around here, and we'll label this distance from A to the center here as X. Now, because the rod is in equilibrium, that implies that the forces going up equal to the forces going down. And so if we use this fact, we have the forces that are going up as 3R and R. So adding these together on the left hand side. And then we have the forces going down, which in this case is 20 newtons. And so if we simplify this, we get 4R equals to 20 newtons. And so R equals to 5 newtons. Another implication of the rod being in equilibrium is that the clockwise moments equal to the anti-clockwise moments. And so if we take moments from A, we get the following. So the clockwise moments are going to be the 20 newtons here, since the moment acts in a clockwise direction from A. And so we have that the moment is equal to the perpendicular distance times the force here. In this case, we have X meters times 20 newtons, which gives us 20x. And then we have the anti-clockwise moments from A, where the first one is this moment here. And so that moment is going to be the perpendicular distance 1 meter times the force, which is 3R. And we know that R is equal to 5. 5 times 3 is 15, and 15 times 1 is equal to 15. We also have another anti-clockwise moment from A at this support here, D. And so taking this moment, we have the perpendicular distance from A, which is 2.5 meters, times the force, which is R. And so 2.5 times 5 gives us 12.5, which we're going to add on. So simplifying this, we end up with 20x, which equals to 15 plus 12.5, which is equal to 27.5. And so dividing both sides by 20, we end up with x equals to 1.375 meters. And so to answer the question, the distance of the center of mass of the rod from A is equal to 1.375 meters.